Okay, so project presentation CIT 206T. So this is our presentation for the course, and we are using our project, the city of Aaron, as a basis for our presentation. So the team members in this project are Leonardo Castellon, Emmanuel Bunia, and Daniel Melo.
So, in this team presentation, we're going to be talking about the 7 steps of the functional development process, which first of all is to clearly define the problem, test metrics, outline the solution, test the algorithm, translate the algorithm into code, run the test cases to verify that the code is working as specified, and finally deploy the changes to the repository. Now, in clearly defining the problem, the method has to deliver the resources that were invested previously in the right storage shared. Resources are classified according to its nature and packed on barrels. Barrels weight can vary depending the resource contained on it.
All right, so the second step is to create the test matrix. So basically we create a table, and we're going to define first the name of the method and its inputs. Inside the parentheses, we have the wagon object, we have a shed object, and the barrel object. And we need the weight and type of the wagon, the type of the shed, the weight, and the number of barrel available in the barrel object. Right after that, we define the returning value of this method. All right, so in the right column, you can go back. In the right column, we have the inputs. We also have the outputs, and also the returning value and the error messages. Then we're going to have our valid cases or invalid cases and the boundary cases. All right, moving on. We have step 3. In this step, we're going to outline a solution. So first of all, we're going to use the if statement to check whether the wagon is empty or not. And we do this by checking its weight. I'm going to check if the weight is bigger than 0. Right after that, we're going to check if the player is in the right location of the storage shed and if it has the right resources in the wagon. So right after that, we're going to calculate the number of barrels needed to transport the whole amount, and we're going to check if there are barrels enough to do so. If it's correct, if everything goes right, we're going to set the quantity attribute in the shed object. We're going to add itself with the wagon weight. So right after that, we're going to set the number of barrels available, and we're going to subtract the number of barrels available in the object barrel by the needed barrels that were the number of barrels needed to do the action. So that's our outline solution.
Alright, so following the outline solution, we'll go to the step 4, which is to test the algorithm. Now, in the test matrix, we have a series of inputs and the resources also, which were also created. Now, in the algorithm, we have series of steps and instructions given for these resources. So in this case, we have the input where we have wagon weight and wagon type. For example, if the input is 400 or a little bit lesser than 400 without having 0 on it, the input becomes valid. So if the input is 400 is valid, and if it is the input is 400 and the wagon type is OR, it is valid. You can also have other instances where the input could be 0 and the wagon type could still contain OR, and when we have cases like this, it shows that it is invalid. And also, another invalid case is where we have a different type of wagon which contains grains and probably must have may have the same wagon weight as that of the ore, which is 400, as we can see in the fourth column here under invalid. That's number 3 for fourth column under invalid. We have grains, which is under the wagon type, and we have the same wagon weight as that of the ore, 400. But because the type does not consist of the same, or it consists of a different material itself, it's marked to become invalid because it consists of a different material itself in the wagon type. And same goes for a higher value, that is a higher input for the wagon weight. If we have the same wagon type as ore and we have the wagon weight equal to 4,000, anything above 400 is also marked as invalid. And then we set a boundary for these inputs, and we have our boundaries for the input, and also for the wagon type we have our boundaries to be 400 for all, and anything higher than that will become invalid, and or anything equal to 0 will become invalid. So the boundary will be set to 400 containing all. Same thing goes to the shed and the barrel weight and the barrel available, and the output will actually give us the summary of mathematical calculation between the barrel weights and the wagon weight. So when 50 is divided by when 50 is divided, the input 50 is divided by 400, the actual output amount becomes equal to 8. And that is that for the step 4. So we are going to create a series of steps and instructions to follow for the program to follow, and when the steps inputs are correct, it gives us the right answer, and when the inputs are invalid, it gives us an invalid, or it returns the value to be an invalid input. So we also have the step 5, which translates the algorithm into code. So having a clear understanding of what we want the program to do for us, we have to put them into code using the code format, which is the if format, which is also a probability format. In case one answer doesn't give us the right answer, in case one doesn't give us a right answer, it is returned back to a particular answer that we expected. For example, if the input was equal to 400, as we said before, if it's equal to 400, then the answer is correct. And if we have the input at first as 0, that is equal to 0 for the wagon weight, we discover it's invalid. So exactly those algorithms that we've created, we'll have to translate them into codes here.
Alright, so step 6, run the test cases to verify that the code is working as specified. So here we have a picture of a test. Here we're testing the deliver resources method. We created each and every step for each one of the correct the valid and invalid and boundary inputs. And in the picture on the right, you can see the attributes, and we're setting the values to into them, and we're using the method assert equals to compare the expected result to the real result and the precision of the result. In the picture in the right, actually, you can see a screenshot of the test after running. As you can see, the test passed at 100%, so all of them went as we expected them to. And finally, after running the test cases to verify if the code is running as specified, we have the step 7. And in step 7, we deploy the changes to the repository. In this part, we're going to merge the code that we created to the existing code in the repository. First of all, actually, I made this port, so I used to do this. I'm not using NetBeans to commit and push and pull the changes. I'm using the bash. And first of all, I use the git add to add the files that were changed. Then I use git commit to commit the changes. Right after committing the changes, I use the git push command to push the changes to the repository. So by doing so, I do the things that I was meant to do. I add the files, I commit the files, and I push the files, and now they're merged with the master branch in our repository.
Alright, so that is the end of the selection and the steps we have to use for the function processing development process. And now we're going to talk about the Java selection statements, as we see right here.
This is the part that Leonardo starts talking about.
Okay. All right. Okay. Thank you. So I have to end it here. I'll
So from that on, he's covering in his